Hello everyone. So in this session, we will be discussing the basic concepts of a quadratic equation. Okay. Now, can we expect a direct question from quadratic equations in CAT? The chances are very low, but questions can be asked in CAT from any area of quantitative aptitude, be it arithmetic, be it geometry, be it any topic which involves application of quadratic equations. Okay, so I consider quadratic equations a very important topic with respect to CAT, and the questions will be based on finding the roots of a quadratic equation. So everyone should know how to find roots of a quadratic equation. Okay, so in this session we'll discuss what is a quadratic equation, how to find the roots of a quadratic equation, sum of the roots, and product of the roots. Okay, now coming to quadratic equation. What is a quadratic equation, or what is a quadratic expression first? Okay, so quadratic expression is an nth degree polynomial or a polynomial where the highest power of x is. Now, what is a polynomial? Any expression in the form x power n plus x power n minus 1 plus so on till some constant term. This is called as an nth degree polynomial, this expression. Now, quadratic expression is a polynomial where the highest power of x in that polynomial is 2. So here the value of n is 2. Okay. So the general form of a quadratic equation will be ax square plus bx plus c. So this is an expression, guys. This is not an equation. Okay, so quadratic expression is of the form ax square plus bx plus c, where a is the quadratic term or quadratic coefficient, b is the linear term or linear coefficient, c is the constant term here. Okay, so how does this expression becomes an equation? So when you equate this to 0 or some number, okay, so you'll be having a quadratic equation. Now, there are two ways to find the roots of any quadratic equation. One is using the factorization method and other is using a formula. Okay, so I consider factorization very easy or very simple, and it takes less time when compared to formula method. And this has some limitations also. Okay, so any shortcut comes with limitation. You can use a factorization method to determine the roots of a quadratic equation when we'll discuss that. Okay, so let's discuss these two methods using an example. So let me consider this quadratic equation x square minus 7x plus 12 is equal to 0. First, let's find the roots of this quadratic equation using formula. Okay, so compare this expression with the generalized form of a quadratic equation or a quadratic expression. Okay, so x square minus 7x plus 12 is equal to 0. Compare this with generalized form of a quadratic equation. So ax square plus bx plus c is equal to 0. Now comparing these two, I can say that the value of a is equal to 1 here, value of b is equal to minus 7, and value of c is equal to 2. Okay, now the formula to calculate roots of a quadratic equation is minus b plus or minus root over b square minus 4ac by 2a. Clear? So the formula to calculate roots of a quadratic equation is minus b plus or minus root over b square minus 4ac by 2a. So here b square minus 4ac is called as discriminant, and we'll discuss this in the quadratic equations class, the importance of this. Okay, so here the value of b is minus 7, so substitute here. So minus b, minus of minus 7 plus 7 plus or minus root over 7 square 49 minus 4ac minus 4 into a 1 into 12 minus 48 by 2 into the value of a is 1 here, so by 2. Okay, so this will be 7 plus root 49 minus 48. One root 1 is 1, so one of the roots is 7 plus 1 by 2 and the other root will be 7 minus 1 by 2. So since this is a second degree polynomial, you will be having only two roots of any quadratic equation. Clear? So one of the roots is 7 plus 1 by 2, 4. The other root is 3. So this is using the formula method. So this formula method can be used for any quadratic equation. Clear? Now let's try to solve this question using factorization. Okay, so we are given with x square minus 7x plus 12 is equal to 0. Okay, so our focus should be on the product of these two, the product of a and c. Okay, compare this with ax square plus bx plus c is equal to 0. So here the value of a is 1 and the value of c is 12. So our focus should be on the product of these two. So 1 into 12, 12. Okay, and now coming to b, this two. So we have to factorize 12 as a product of two numbers such that the sum of those two numbers is minus 7. So how can you factorize 12 as a product of two numbers such that the sum of these two numbers is minus 7? Or first let us consider the magnitude of this number, the value of this number 7, and then we'll discuss about the sign. Now how can we write 12 as a product of two numbers such that they add up to 7? 4 into 3. But 4 plus 3 is minus 7. Sorry, 4 plus 3 is 7. But we need to have minus 7. Okay. So this can be written as minus 4 into minus 3 is equal to 12 and minus 4 plus minus 3 is minus 7. Okay. Now what I will do is I will rewrite this expression as x square. I will split this 7x into minus 4x plus minus 3x. So minus 4x plus minus 3x, which will be minus 3x plus 12 is equal to 0. Okay, so what can I take common in these two terms? X. So x into x minus 4. In these two terms, I can take minus 3 common. X minus 4 is equal to 0. Okay, now in these two terms, I can take x minus 4 common. So I can rewrite this equation as x minus 4 into x minus 3 is equal to 0. Now, if product of two numbers is equal to 0, then one of the numbers should be 0, isn't it? So you can have either x minus 4 is equal to 0, which implies x is equal to 4, and or x minus 3 is equal to 0, which implies x is equal to 3. Clear? So these are the two roots of this quadratic equation. Clear? Or if you end up with this minus 4 minus 3, so I can rewrite this quadratic equation as x plus this, x plus minus 4, x minus 4 into x minus 3 is equal to 0. Clear? Now let's solve one more question for practice. So we are given with x square is equal, x square minus 11x plus 24 is equal to 0. So comparing this with ax square plus bx plus c, a is equal to 1, b is equal to minus 11, c is equal to 24. Now finding the roots using formula method. So minus b. So minus of minus 11. 11 plus or minus under root 11 square. 121 minus 4 into 24. 96 by 2. So 121 minus 96 is 25. 25 square root of 25 is 5. So one of the roots will be 11 plus 5 by 2. The other root will be 11 minus 5 by 2. So 11 plus 5, 16, 16 by 2, 8, 11 minus 5, 6, 3. So 8 and 3 are the roots of this quadratic equation. This is using the formula method. Okay. Now using factorization, x square minus 11x plus 24 is equal to 0. Okay. Now product of A and C, 1 into 24, 24. Now we have to write 24 as a product of two numbers which add up to minus 11. So 24 can be written as minus 8 into minus 3. Okay. So x square minus 8x minus 3x plus 24 is equal to 0. So I can take x common, x minus 8. I can take minus 3 common, x minus 8 is equal to 0. So x minus, now I can take x minus 8 common in these two terms. So it will be x minus 8 into x minus 3 is equal to 0. So the value of x should either be 8 or 3. Clear, guys? So first, whenever you come across any quadratic equation, first find whether you can solve that quadratic equation using factorization, because it's not mandatory that every time you can write the product of these two numbers as product of these two into two numbers which add up to minus 11. It's not mandatory, isn't it? If, for example, uh, x square minus 7x plus 14 is equal to 0. Now you will be having the values of x for this equation which need not be integers. Okay, so you cannot have the sum the you cannot express 14 as a product of two numbers which add up to minus 7, isn't it? So in these type of equations, it will be better to use the the formula method, and whenever you can write this the product of A and C as a product of two numbers which add up to the linear term or linear coefficient, it's always better to use the factorization method. Clear? Now, the sum of the squares of two consecutive positive integers exceeds their product by 91. Find the integers. So these are some types of questions, board problems, which can be which are based on quadratic equations. Now the sum of the squares of two consecutive positive integers. Okay. So if I consider one of the positive integer as x, the other positive integer can be either x plus 1 or x minus 1. So if I consider x is uh, the minimum positive integer between these two, the lowest between these two. So the next consecutive positive integer will be x plus 1. Now we are given that the sum of the squares of two consecutive positive integers. So squares of these two, x square plus x plus 1 whole square. This exceeds the product by 91. So what will be the product of these two? X into x plus 1. Okay. Exceeds the product of these two numbers by 91. So product of numbers plus 91 should be equal to the sum of the squares of these two numbers. So by expanding this, we will be having x square plus x square plus 2x plus 1 is equal to x square plus x plus 91. Okay. So we will be having x square plus 2x minus x minus 90 is equal to 0. Okay, so x square plus x minus 90 equal to 0. Now product of these two minus 90. Now can we write minus 90 as a product of two numbers such that the sum of these two numbers is plus 1? Yes, 10 into minus 9. Clear? So I will be splitting this equation, or I will be rewriting this equation as x square plus, I will be writing this x as plus 10x minus 9x minus 90 equal to 0. Isn't it? So I can x into x plus 10 minus 9 into x plus 10. So x plus 10 into x minus 9 is equal to 0. So the value of x can be either minus 10 or x is equal to 9. But in this question that we are given that these two are consecutive positive integers. So none of these two can be negative. So the value of x cannot be minus 10. Okay. So these two integers are 9 and 10. Clear? Now find all the possible values of x is to y if x and y are non-zero numbers such that 6x square minus x5 is equal to 15y square. Okay, so we need to find the possible values of x by y. So how can we have x by y from this equation? So I have to divide both the sides by y square. Okay, so you'll be having 6x square by y square minus x by y is equal to 15. Or if I consider x by y is equal to some variable k. So this equation will be 6k square minus k minus 15 is equal to 0. Now what is the product of 6 and 15? 90. So how can I write 90 as a product of two numbers such that they add up to minus 1? Minus 10 into 9. So I'll be rewriting this equation as 6k square minus, you can either consider 10k or 9k, minus 10k plus 9k minus 15 is equal to 0. Now what can we take common in these two? 2k. So if I take 2k common, 2k into 3k minus 5 plus, in these two I can take 3 common. 3 into 3k minus 5 is equal to 0. Now in these two terms I can take 3k minus 5 common. So this will be 3k minus 5 into 2k plus 3 is equal to 0. Now the value of k will be either 5 by 3 or minus 3 by 2. Now k is nothing but x by y. So the possible values of x by y are 5 by 3 or minus 3 by 2. Clear? Now moving ahead to sum of the roots and product of the roots of a quadratic equation. Now for any quadratic equation in the form ax square plus bx plus c is equal to 0, we have sum of the roots as minus b by a. So if alpha and beta are the roots of this quadratic equation, alpha plus beta will be equal to minus b by a. And if alpha and beta are the roots of this quadratic equation, then product of the roots alpha into beta or alpha beta will be equal to c by a. Clear? Now the factorization, the concept behind factorization is this. This is equal to sum of the roots, and b by a is nothing but sum of the roots, and c by a is nothing but product of them. Okay. Now, given with roots, we can form quadratic equation easily by finding the sum of the roots and product of the roots. Okay. For example, given that the roots are 2 comma 3. So what will be the quadratic equation? Or we have that in our next slide. If the roots of a quadratic equation are p and q, then the equation can be constructed as x square minus p plus qx plus pq. Okay, so x square minus sum of the roots into x plus product of the roots. Okay, so if you are given that the roots are 2 comma 3, one way of forming a quadratic equation will be x minus 2 into x minus 3 is equal to 0. So which is nothing but x square minus 5x plus 6 is equal to 0. Now the other way is using this x square minus sum of the roots, sum of 2 and 3, 5x plus product of the roots 2 into 3, 6 is equal to 0. Clear? Now, if the roots of the equation are p and q, then ax square plus bx plus c is equal to a into x minus p into x minus q. So this is what we have done. Clear? Now, if the quadratic equation 4x square minus kx minus 4 is equal to 0 has sum of the roots as 1, find the value of k. Now, we are given with sum of the roots. What's the formula to calculate sum of the roots? Minus b by a. So compare this equation with ax square plus bx plus c is equal to 0. So here the value of b is minus k and the value of a is 4 and the value of c is minus 4. Now we are given that the sum of the roots is 1. So formula to calculate sum of the roots is minus b by a, which is equal to minus of minus k by 4, and this is given to be 1. So k by 4 is equal to 1, or the value of k is 4. Now find the value of b if x plus 3 into 2x plus 5 is equal to 2x square plus bx plus 15. So one way of solving this question is just by expanding this, you can compare the the coefficient of x on LHS and x on RHS, you will directly get the value of b. Now the other way of doing this question, okay, let me do it in that way as well. So you will be having 2x square plus 11x plus 15. This is equal to 2x square plus bx plus 15. Okay. So 2x square, the coefficients of x square is same and the constant is same. So the value of b should be equal to 11. Or what are the roots of this quadratic equation given that x plus 3 into 2x plus 5 is equal to 0? Roots are minus 3 and minus 5 by 2. Now what is the sum of these two roots? Minus 3 plus of minus 5 by 2, which is equal to minus 6 minus 5 minus 11 by 2. Now in this quadratic equation 2x square plus bx plus 15, what will be the sum of the roots? Minus b by a, where the value of a is 2 here. So minus b by 2 is equal to minus 11 by 2, or this implies b is equal to 11. Okay, so we will be having some more models where we will be using the concept of sum of the roots and product of the. Clear? So the last question of the session. The equation x square plus 8x minus 9 is equal to 0 has roots alpha and beta. Find the value of alpha by beta plus beta by alpha. Okay. So we need to find the value of this expression. So first, let me take the LCM. LCM will be alpha beta, and in the numerator, we will be having alpha square plus beta square. Now a square plus b square can be written as a plus b whole square minus 2ab. So alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta by alpha beta. So this is nothing but alpha plus beta whole square by alpha beta minus. Now what is if alpha and beta are the roots of the equation, alpha plus beta is nothing but the sum of the roots, alpha beta is nothing but product of the roots. Now sum of the roots is minus b by a. So minus 8 by 1 minus 8 whole square by product of the roots c by a minus 9 by 1 minus. So this will be nothing but 64 minus 64 by 9 minus 2. So 64 plus 18 minus 82 by 9 should be the answer for this question. Clear? So any indirect question from quadratic equation which has application in one of the other concepts, okay, will be based on finding the roots of the quadratic equation. Okay, so in the session we will be discussing how to determine the nature of roots, the remainder theorem, and finding the product of the roots and sum of the roots of an nth degree polynomial. Okay, so in case of any doubts, just get back to us. Thank you guys.